A field worker has a long strip of sheet steel 12 feet wide. She wishes to make an open-topped water channel with a rectangular cross section. If the cross-sectional area must be 16 square feet, what should the dimensions of the channel be? Now, first off, I want you to visualize what's happening here. Sheet steel is just like, it's a piece of steel, it's like on a, imagine aluminum foil, all right, but wider and thicker, okay? So it's a 12 feet wide, so basically open up your Reynolds Wrap aluminum foil box, it's 12 feet wide, you grab it and you start pulling it out, and you pull it out as long as you want to, right? So that's what's happening. So she has this long piece of sheet steel, if you just visualize that, she happens to have red aluminum, red steel, must be rusted or something, I don't know. Anyway, she's going to fold up along here and along here. So she basically has this long piece of steel, folds up the sides, and it creates like a gutter. That's what an open channel is what she's talking, open top channel. So she's allowing a place for like water or something to travel down that path, right? So this dimension here is the 12 feet wide. It says it's 12 feet wide. It says a long sheet. It didn't tell us how long the sheet is, so this dimension probably isn't going to help us at all. Okay. I want you to visualize this long sheet and her folding it up, and then don't look at it from above, look at it from the end of it. All right, so you're looking at a gutter from the end. When she folds it up, that's what it looks like. If you're looking down the gutter, you know, it's going out this direction here like so, right? But this right here is the piece we're talking about. So again, imagine this long gutter like that. We're looking at the cross section of it, so if you just chop off the end of the gutter and look at it along this like down the gutter instead of above the gutter or front of the gutter, so you're looking down it. So basically what we're looking at here is that represents an open top. Every gutter I've ever seen has no top. Otherwise the water doesn't go in. Unless you get one of those leaf filter ones, right? Unless the water go through, the leaves don't. Might be looking at that. Notice that this whole piece here, from here around to there, back up to there, would be 12 feet, right? I don't know how big each of these sides is, I don't know how big that is, but I do know that she folded up some amount, we'll call it X inches, or sorry, X feet. She folded up the same amount over here, which is also X feet, right? The entire width of that piece is 12 feet. You fold up X and X. The leftover amount down here is going to be 12 minus 2X feet. Somebody not follow that? So again, just looking back here, this is what she folded up, that's X. This is what she folded up, X. This is the bottom of that piece over there. It's 12 minus 2X's to make the leftover bit. All right? So there's our circular, or so there's our rectangular cross section. Rectangular cross section this time. And the dimensions are known, XX and 12 minus 2X. Now, it says the cross-sectional area must be 16 square feet. So the area of this rectangle has to be 16 square feet. And the area with the algebraic pieces, length times width, would be X times 12 minus 2X. That should equal the actual area that we want, which is 16 square feet. So this is the other type of problem we're dealing with in this section. One type, they give you an equation, they tell you what all the variables represent, they tell you what some of them equal, and they ask for another one, right? And then we have some that involve geometric properties that allow us to use geometric equations in order to find out equations for what we know and what we don't know. So we need to create a geometric picture using algebraic sides, using as few variables as possible. And then area, length times width, equals the given area 16. All right. If I distribute that x through the parentheses, x times binomial is x times 12 and x times negative 2x, that gives me 12x minus 2x squared equals 16. And at this point, I'm going to diagnose the problem as far as how am I supposed to solve the problem using algebra, right? I've got a quadratic equation because x squared's in it. X to the first is also in it, so I've got to use the quadratic formula. I'm going to erase this. It did its job. So have room to work it out. So first thing I'm going to do is I'm going to use the quadratic formula. I want it equals 0. And my favorite structure when I'm doing the quadratic formula, I like x squared to be positive. X squared currently is negative where it's at, so I can either move everything to the right, which would make x squared positive, or I can move everything left, keeping x squared negative. Yes, Ashton?
When you put x times 12 minus 2x, where did you get that extra x from?
This x, this x, this x? Like, I don't know which extra x you're talking about.
Well,
Like
you
down
already
here?
got 2x from the two x's, so then where's the extra x on the left come from?
This x. So,
No, not. Never mind.
all right.
That's not what I'm talking about.
Well, hold on. I just want to make sure you understand everything. So, this right here is this piece,
Yeah.
and this right here is this piece,
Yeah.
and that right there is that piece, right?
Yeah.
So then, x, x, and 12 minus 2x would be the rectangular piece right here, right? So rectangle opposite sides are equal. This would also be 12 minus 2x if it had any measurement, right? So then, length times width equals area. So area was 16, that's where I got 16 from. So length 12 minus 2x times width x equals 16. And since 12 minus 2x is a binomial, I need to multiply one thing times more than one thing. X times 12 is 12x. Is this the extra x you're talking about? This?
Well, because where'd you get 2x from?
2x.
Yeah, where'd you get 2x?
That's 1x.
Yeah.
That's 2x.
Yeah.
This whole thing's 12.
But then where'd you get the other x that you multiply 12 with?
Length times width. It's a rectangle. Area of a rectangle is equal to length times width. The length is 12 minus 2x. The width is x. You don't see it?
Just go on.
Okay. All right. Okay. So again, I want 12 minus 2x squared. I want 2x squared positive, so I'm going to move everything to the right. So I'm going to get 0 equals positive 2x squared because it moved to the right, negative 12x because it moved to the right, and plus 16 because it already is on the right. Okay. So minus b is equal to positive 12. 2a is equal to 2 times 2, which is 4, because again, a is this number, b is this number, c is that number. Signs matter. So, b is negative 12, minus b, change the sign. A is positive 2, 2a is double up, 2 times 2 is 4. b squared minus 4 times a times c is going to be positive 144 minus 4 times 2 times 16. 16. Was it 16? So b squared minus 4ac is equal to 16? Right. 4 times 2, 8 times 16, 128. 144 minus 128 equals 16. So, I know that x is equal to this structure. Minus b goes in front of the plus minus, b squared minus 4ac goes after the plus minus, 2a goes in the bottom. The square root of 16 is 4. So we get something over 4 and something over 4. The first something is 12 plus 4, which is 16. Second something 12 minus 4, which is 8. So x equals either 4 or 2. X is 4 feet or 2 feet. And it says, what are the dimensions? What should the dimensions of this channel be? So there's two different answer choices, right? Okay, we have to make sure both answer choices are possible. So the dimensions, again, our length is 12 minus 2x, and our width is x. So if x equals 4, my length is going to be 12 minus 2 times 4. So the length is equal to 12 minus 8, which is 4. The width equals x, which is 4, so that's one set of answers, 4 feet by 4 feet. 4 feet by 4 feet. That's if she folds 4 feet up on both sides. If x equals 2, my length is going to be 12 minus 2 times x. 12 minus 4 is equal to 8. Width is x2, so that'd be 8 feet by 2 feet. Either one of those would work. Right. Notice if length and width are 4, 4 plus 4 plus 4 is 12, right? 4 times 4 is 16. If 8 and 2, 2 plus 8 plus 2 is 12, and 2 times 8 is 16. So either way, you fold up 2 feet on both sides. You have 2 feet on the sides, 8 feet across the bottom, your area is 16. If you fold 4 feet up on both sides, you have 4 here, 4 there. You get yourself a 4 by 4, 16 area as well.